Hi GOR, this is Unit 3, Lesson 4, and today we're going to do all different types of proofs. So remember, we're really just marking our diagram with the given. Any keywords like midpoint or angle bisector or perpendicular lines will allow us to write other statements, and then we write the reasons for those statements. So again, there's 5 ways to prove triangles congruent: side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse, leg. So you're going to mark your picture. So it's important to mark the picture. That's not really being graded, but it's important so that you know when you're done with the proof and when you can say the triangles are congruent and what's the reason. So statement 1 is going to be my given. I always put my given all in one step. There's no reason to have it in separate steps. I'm going to mark this on my picture as well. So AC is congruent to AD. And CB, I'll do 2 little slash marks there, is congruent to BD. And my reason is given. And that's all my given. So at this point, you just have 2 things on your diagram marked. You have to see, do they share a side? And you can mark that shared side. Or do they have vertical angles? So those are 2 things that are not going to be in the given that you have to mark yourself. And these 2 triangles here share side AB. So I put an X on AB, and I say that AB is congruent to AB. Anything is congruent to itself by the reflexive property. Now, I start my proof with the given. I'm done with my proof when I can prove what I wanted to prove. I wanted to prove these triangles are congruent, and if you look at my picture, I can now say the triangles are congruent because I have 3 sides in one triangle congruent to 3 sides in the other triangle. So triangle ABC is congruent to triangle ABD by side, side, side. So side, side, side is my favorite proof just because it's a little bit easier usually. You don't have to worry about is the angle between the sides or not between the sides. All right, so here we go. 2. I have HI is congruent to GJ. So I'm going to write that as step 1. HI is congruent to GJ. And HI is parallel to GJ. All right, so HI is congruent to GJ and they're parallel. So the parallel symbol is that little greater than symbol. And that's all my given. All right, so I only have one side. The reason that they would tell me that parallel lines is because usually when we have parallel lines in a proof, you're going to be able to say the alternate interior angles are congruent to each other. So look where I'm putting the 1 and the 2. You can put numbers onto your proof and then you can use the numbers in your statement rather than using the 3 letters for the angles. So parallel lines make usually alternate interior angles congruent. It's either alternate interior angles or corresponding angles, but you can see, so these are my parallel lines, this is my transversal, these are my alternate interior angles, and they're congruent to each other. So that is in that those 2 triangles right there. So I'm going to say angle 1 is congruent to angle 2. Now I don't say definition parallel lines because that's not the reason. The reason is alternate interior angles are congruent. All right, and notice in my proof, HJ is in both triangles. So HJ right here is a shared side. I put an X on it, and any shared side, I say that side is congruent to itself. So HJ is congruent to itself. The reason is reflexive property. Think about it. When you look in the mirror, you see your reflection, you see yourself. You're congruent to yourself. Now I'm marking my picture because I want to know when I'm done, and I have to be done because these proofs were set up so the number of steps match exactly. And my last step always has to be what I'm trying to prove. So triangle GJH is congruent to triangle JHJ. Oh no, it's IHJ, sorry. And I have 2 sides and an angle, and the angle's between those 2 sides, so it's side, angle, side. Next one, I have angle BAC. Angle BAC is congruent to angle DEC. I'm going to mark that. BAC, see how I follow the order of the letters, is congruent to DEC, the E's in the middle. So right where the E is and right where the A is, those are my congruent angles. The middle letter is the vertex of your angle. And C is the midpoint of AE. And all of that is a given. So I mark the congruent angles. Now C is the midpoint of AE. That means it's only cutting AE in half. This is AE, the line that I just drew in red. C is the midpoint of AE. It cuts AE in half. It is not cutting BD in half because they didn't tell me that. I mark my two sides congruent, and I say AC is congruent to CE. The reason is definition midpoint. So remember, a midpoint is, I call it a key word. A midpoint is something in the given that will allow you to say make another statement, in this case, that the two sides are congruent, because a midpoint divides a segment into two congruent segments. So AC is congruent to CE, definition midpoint. And that's all my given. So when you're done with your given and you don't have enough marked on your picture to prove one of those 5 ways, then you have to say, do they share a side or do they have vertical angles? And these two particular triangles have vertical angles. So I'm going to call them angle 1 and angle 2. See how I'm marking them congruent? As long as the numbers are on the picture, then you can use it in your proof. Angle 1 is congruent to angle 2. Vertical angles are congruent. And then again, my last step is always what I'm trying to prove. So triangle ABC is congruent to triangle EDC. And look at your picture. I have 2 angles in one side. The side is between the 2 angles, so it's angle side angle. All right, I have a few more. I'm just going to do 4 and 5, and 6 we'll do together in class, or I'll let you guys try it more rather than do it together in class. So this one has perpendicular lines. That's one I want to make sure that we do. And I also have a midpoint. So all of that is in statement 1. YZ is perpendicular to WX. Z midpoint of WX. So I got 2 things going on that will give me other statements. Perpendicular lines make right angles. So I'm going to mark my picture. YZ right here is perpendicular to WX. So these angles 1 and 2 are right angles. Statement 1 is just a given. Statement 2, perpendicular lines make right angles. So first I'm going to say angle 1 and angle 2 are right angles. And we did all of this in lesson 1. The reason that they're right angles is because the lines are perpendicular. So I just write definition perpendicular lines. Now if they're both right angles, that means they're both 90, which means they're congruent to each other. So these 2 steps always follow. Perpendicular lines make right angles. Right angles means that those angles are congruent to each other. So angle 1 is congruent to angle 2 because all right angles are congruent. Now I also had a midpoint in my given. If Z is the midpoint of WX, that means it's cutting WX in half. So I put a big dot on Z and I say WZ is congruent to ZX. I say those 2 halves are congruent. How do I know they're congruent? Because it was a midpoint. And a midpoint divides a segment into 2 congruent segments. But I say definition midpoint. You do not need to write out the whole definition. They share YZ in the middle. Always look for a shared side because that's a nice, easy step. The proofs, you're always getting partial credit on them, so you write as much as you can. So YZ is congruent to YZ, and the reason is reflexive. And my last step is always what I was trying to prove. If you look at my picture, I have side angle side. I have 2 sides and the angle between them. So the triangles are congruent by side angle side. Okay, last one that we're going to do together. So AB is congruent to DE. I'm going to mark that. You always want to be marking your picture because there's going to be a lot of stuff going on, and you need to know why the triangles are congruent. AB is parallel to DE, and C is the midpoint of AE. All my given. Okay, C is the midpoint of AE. C is the midpoint of AE. C is the midpoint of AE. It cuts AE in half. See how I'm marking those? Oh, I got to do two things on those. C is the midpoint of AE. It means it cuts AE in half. So I can actually say, I marked it on my picture, but the picture is really just for me. I need to write the statement, AC is congruent to CE. And the reason is definition midpoint. For those of you who don't have a printed packet, you can just draw a quick little, sketch of the graph, of the picture. It doesn't have to be perfect by any means. All right. And then I had parallel lines. The fact that the lines are parallel means that there are alternate interior angles that are congruent to each other. So I'm going to put a 1 here by the A, and I'm going to put a 2 here by the E, and I'm going to say angle 1 is congruent to angle 2. I could have called them angle A and angle E. I like to use numbers. So angle 1 is congruent to angle 2, and the reason is alternate interior angles are congruent. Now I also have vertical angles here, but I don't need it because I already have side angle side. So I'm done. Let me just see if I left a step because I have too many things here. I guess I put the vertical angles in. That's why I have an extra step. But you don't need the vertical angles. If you wanted to write them, you certainly could in step 4. So I'm going to cross out step 4. I already have enough to say that my triangles are congruent. So triangle ABC is congruent to triangle EDC. And the reason is side angle side. Now, if you had the vertical angles, I'll just put them in here, like say you called them 3 and 4. Then you could have also said these triangles are congruent by angle side angle. Okay, so if you had the vertical angles, you could have done angle side angle. When you're doing a proof, they're not going to be numbers like this, so you won't know how many steps there are exactly. You're just going to do it until you can finally prove what you wanted to prove, and that's why you want to mark the diagram. So we'll do 6 tomorrow in class, along with the other practice.